Hello, let's continue our advanced Sudoku series with Chicane by Shye. So, this is puzzle number 3 of chapter 6 of the Sudokult Gospel document. As always, I know what technique I'm looking for and how to explain it, but not exactly where it is in this puzzle. There is a link in the description if you want to try the puzzle yourself, or as well as a link to the entire document. And I'm going to get started right now. All right, I think there's some pretty obvious spots to be looking for filling some cells right away. So let's take a look at that first. So this can be 1, 2, can't be 3, 4, 5, 6, 7, 8, 9. This can be 1, can't be 2, could be 3. Could be 4, can't be 5, 6, 7, 8, 9. Let's go to the corners here. We need 1, can't be 2, 3, 4, 5, 6, 7, could be 8. Over here, in fact, let's just do this whole row. We need 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, nice. Those are all by values there. How about up here? We need 1, 2, 3, 4. Cleans up pretty well too. Okay, let's just do the entire border. So these are 1, 2, 7, 9. That's not 7, that's not 9. And these are 1, 3, 4, 8. That's not 3, 4, that's not 8. Oh, we have a 1, 8 pair here. Just making sure, yes, he's 3, 4. Okay, so that's a 3, 4 pair. Nice. Let's do this triple in the middle. 1, 2, 3, we need 4, 5, 6. That's not 4, that's not 5, that's not 6. Okay. I'm wondering if we should be on the lookout for more, or if this is enough. Maybe I should just do some normal scanning, because the normal scanning will still help even after we find the needed technique. So there's a 7 in one of these two. I'm pressing page down. That is not 7. Okay. 8's in here somewhere too. 6's are here. 5's are here. 9's are here. 9, 5, 6, 7, 8, 9. 7, 8, 9. Okay. Over here we've got 2, 4, 5, 6. 2's are here. I don't really want to mark that. 4, 5, 6. Okay. Down here we've got 3, 5, 6. So the 5 is here. The 3 joins the 5. That's a hidden 3, 5 pair. What's that leave here? 6, 7, 8, 9? This isn't 8, 9, so this is only 6, 7. This isn't 7, 9. So this is only 6, 8. Interesting. We got a lot of bi values in this puzzle. Anything else going on here? 3, 5, 6. 5, 6. 3. How about 1, 2, 4? 2's. Okay, so yeah, 2's are over here, but I'm not marking that. How about vertically? We got all our 5's. How about 4? Nothing with 4. 5, 3, 6, 8. 6's are here. Okay. We actually didn't do this vertical. It's just almost full anyway. There's a 2 in one of these two. What's this cell? This seems limited. It's not 1, 2. Could be 3, 4. It's not 5. Could be 6. Actually, can't be 6, 7, 8, 9. Another bi value. Okay. This cell seems limited too. So it could be 1. It's not 2, 3. Could be 4. It's not 5, 6, 7. I think it could be 8 though. Okay. One of the few non-bi values in this grid. I think this vertical's good. Let's do this vertical. Actually, is there something 6, 7, 8? Hold on, 9's a single in this box. I didn't actually notice that. So let's place the 9. Okay. Weird that I didn't spot that. There's a 9, one of these two. 8's no good. 3's here. Okay, 2's look up, right? So 2's one of those two. Okay, these are probably limited because I mean they're not the 2 or it's the other one. Like this one's not 2 or 6 or 3 4. So what do we need? What are these 4 digits? Let's just fill them all. We need 1 2. We have 3 4. We need 5 6. We have 7 8 9. Okay, yeah. So they all clean up quite nicely. Alrighty. How about over here? Do these clean up? 1 4 6 7 8. 1 4 6 7 8. Not really. Okay. Over here, we need 1 2 3 4 9. Not really. Okay. I think we might have found most of what we need, if not all of what we need. Okay, so what we're looking for is an XY chain, which you may have figured out from all of the different bi values going on here. So how does an XY chain work? Well, you're worried about the bi values in the grid. And if you were looking for an XY chain, it never hurts to just highlight all your bi values and then just make them green or something. Bi values being a cell that's limited to 2 values, bi value. And so now so like, let's think about this corner here, right? It's got 2 options. It's either a 1 or a 2. So if it's a 1, it has some effect. If it's a 2, it has some effect. So what we want to do is we want to just pick something. Like let's pick the 2 for not a whole lot of good reason, just to demonstrate. So it's either a 2, in which case it's a 2, right? That's one case. The other case is it's a 1. So I'm actually going to remind myself that I started here. I'm going to make it like a different color, like purple. And I'm going to put 1 corner mark to say I started with 1 so I don't forget. But from 1, we can get, and what we're going to do is we're going to follow around the bi values. Like 1 makes this a 7, right? 7 makes this an 8. And I'm going to go until I find something that becomes a 2. So 1 makes 7, which then makes that 8, which makes that 1, which makes that 8. And we kind of get stalled there. So let's backtrack. So 1, 7, 8, that makes this 6, 4, 1. I mean, I just found a contradiction. I mean, I could use that. So 1 is not possible in this case, because if I start with 1 here, I get 7, 8, 6, 4, 1. So I'd have 2 1s in the row. Or alternatively, this would have no value. So yeah, if that's a 1, then we're directly saying it should be a 4, but we're also indirectly saying through this chain that it's supposed to be a 1. So, or that it can't be a 4 at the very least. So this cannot be a 1. This is a 2, and I think that's just going to finish our puzzle. I don't need any of these greens. So we get our 3, we get our 4, our 3, 1, 4, 5, 6, 4, 5, 7, 3, 8, 6. That's not a 6. The 8 is placed here. So is the 2 and the 7. 1, 7 pair. This is a 9. That's a 9. We get our 1 and our 8. We get 7 and 1. Okay, what else is going on here? We get our 2, which gets our 6. We get 1 5 pair. All right, I'll clean up the rest of this, and then we will pencil the rest, I guess. I'm sure the rest just finishes. 1 2 3. We need 4 and 9 here. Okay. Here we need a 1 and 3. Okay. How about this row? We need 1 2 3 4. Okay. The 2's over here. These aren't 4, these aren't 2, that's not a 3. Okay. Here we've got 3 digits left. 3, 4, no, not 4, 3, 7, 8. So this can't be, finally, this can't be 3 or 8. So use the 3 here and the 8 here. So that's the 7, that's the 3, that's an 8. This is not a 3. 1 4 pair means those aren't 1s. This is a pair. Actually, this is a single. It's even better. That's a 5. Gets us the 1 and the 5 and the 4 and the 1. Over here, we do need a 1. and a 7. Okay, that given 7 up there tells us the order. 1, 7, 3, 1, 2, 3. All right, let's play what does this box need. It needs a 2. That goes there. It needs a 4. Literally anywhere. It needs an 8 and a 9. So the 8 can go here, the 9 can go here. All right, let's play what does this box need then. We need a 4. The 4 can go here. We need a 6. The 6 only goes here. We need a 7. The 7 only goes here, which gives us the 4. And our final digit is an 8, and then this all resolves, and the above resolves, and we're done. Nice. There were probably a bunch of XY chains that could be found there. That wasn't even your typical XY chain, because it kind of ended in a contradiction. There might have been like a different way to see the same chain that didn't involve a contradiction, but I mean, that was perfectly fine logic. A more typical XY chain would have you like prove that one of two things must be, and in this case, I was trying to prove a 2. So like this, either this is a 2, or we go around a bunch of bi values and this ends up a 2. And so then that means one of these two must end up a 2, right? And then you can eliminate those and those as 2s, just as an example. And now they could both be 2, but they can't both not be 2, if that makes sense. So yeah, similar to like the AIC. In fact, it is an AIC, but it's kind of like it's a kind of AIC you can look for if you got a bunch of bi values that is much easier to track and follow than your typical AIC would be, like a generic one. So pretty useful thing. If I'm ever stuck in like a difficult classic, I always look for an XY chain. You don't always find one, but when you do, it's usually going to crack your puzzle. So anyway, hope you enjoyed this. And if you did, then why don't leave a like, subscribe, and a kind comment below.